So welcome everybody to Restore the Shore. My name is Caroline Barnett. I am a first year graduate student in the Department of Agricultural Education and Communication at the University of Florida. With me today, we have Taylor Nash, who is operating the live cam. I don't know if you want to turn it on yourself. Okay. No, he doesn't. Okay. Um, who's here with us today. And then we also have Dr. Lewitzo, the director of our program. And then, of course, we have our scientist, Dr. Mike Allen, who will be talking with you today. And I just wanted to go over that if you have any questions, feel free to write them down or to put them in the chat for the Zoom, or we will also have question breaks throughout the presentation and at the end of the presentation, and you can ask questions to Dr. Allen. And if you have any other questions, let me know. But with that, we will get started. Yeah.
Thank you, Caroline. And hello, everyone. It's good to see you today. My name is Mike Allen. I'm a fisheries scientist at the University of Florida and director of our Nature Coast Biological Station here in Cedar Key, Florida, which is only about 2 hours north of Tampa on the Gulf of Mexico coast. So what I wanted to start today with is to show you our Swanee River alligator snapping turtle named Wilbur, because he has his mouth open. This is Wilbur. You can see in the camera that Taylor's showing, as well as here. This is an alligator snapping turtle. It's the only turtle in the world that has a tongue that has evolved to look like an earthworm. So it actually sits for hours at a time, and this turtle can hold its breath underwater for over 2 hours. And it sits there with its tongue out, and it looks like a little earthworm. And the fish will come in and try to eat that earthworm, and then it snaps down on them. And this turtle has a bite that is 3,000 pounds of pressure per square inch, over that of an alligator, an American alligator, and quite a voracious bite it has. Now, these are not dangerous per se. You obviously wouldn't want to get bitten by one, but they don't come lash out at people. But they're found in the rivers around the Gulf of Mexico. This particular species is endemic to the Swanee River in particular, and really a neat animal. So it's not asleep. It's laying there hoping that a fish is going to come get in its mouth. But the fish that are in here, right now there's very few fish in here, and those that are in here are usually pretty wise, pretty quick, so they don't get much caught. So this is Wilbur, and feel free to come see him if you're ever here in Cedar Key. These turtles are available, and they're in the neighborhood where your high school is as well. They live in freshwater environments, but you almost never see them. They have this little pointy nose you can see here, just a little pointy nose with a couple of nostrils. And really, most of the time, all they do is stick the little nose out and get a breath of air and go back down. And you would almost never see these animals in the wild. Occasionally, you'll see one out of the water. Usually when they go to breed, they come out of the water, but besides that, they're in the water and almost completely invisible. So I wanted to introduce you to Wilbur right away because his mouth's open, and you can see that. So I welcome you, and I'm really glad to have you in your class today here in our biological station. I'm a fisheries scientist, and today we're going to talk some about fisheries. Now, while we're here, I'll say a couple things. One is I just wanted to make the point that, you know, in your careers, you can pursue careers doing all kinds of things. When I sat in your seat in high school, I didn't even know you could be a fisheries biologist. But I've become a fisheries biologist and work. My passion growing up was fish and wildlife and outdoors, and I was able to follow that into the position that I'm in now. And I just encourage you that, you know, to pursue your passion, and that if you're interested in fish and wildlife or outdoors or whatever it may be, there are careers there to do that. If you're interested in that and you want to contact us, let your teacher know. She will contact Dr. Jamie, and they will get a hold of us if there's questions. So we're happy to talk to you even after this session as well. While we're here, we're going to do a little tour of the lab here and show you around. And this is our 1,400-gallon aquarium here. And we got some big fish in here. These are down below our red drum. The one up high that has the white stripe is a cobia. That's a cobia, which is a tropically globally distributed fish. You can find cobia around the world. In our part of the world, they're here in the spring and summer and into fall, and then in the winter they move south and actually make large migrations. This fish on the screen right here behind me is a snook, also a very common sport fish in Florida. Some of you may have caught a snook before in your region. Raise your hand if you've ever caught a snook. Oh, I see some hands in the back. I see at least 3, unless somebody raised 2 back there. So that's good. Snook are a really popular game fish and a species that we're going to talk about. Now, the ones on the screen below that you see right now, that's a redfish called red drum. Also a very iconic Florida sport fish. And these are in our aquarium here. We feed these fish frozen shrimp and frozen threadfin herring, and they eat voraciously, and they're great. These are a wonderful exhibit to people, and they're examples of fish species that are of importance to Florida's economy and recreational fisheries and that kind of thing. So, so just an overview there of the aquarium. And the next thing I'll show you is just to orient you on kind of where we are. I'll show you this map. And this is a map of the Nature Coast region. Now, Tampa Bay is down here. This is Tampa Bay. This is the Gulf of Mexico. And here is where we're located right now. So Tampa Bay is a couple hours south. We're in Cedar Key, which is just south of where the Swanee River dumps into the Gulf. And the Swanee River Basin is indicated by these lines here. So the Swanee River is one of the largest undammed rivers in the eastern U.S. There's not a single dam on it, which is really unique. Most river systems in the United States have a lot of dams for things like hydroelectric and flood control. This system is natural, and I think it will probably remain that way. And that it's a free-flowing natural system, which is really neat. So we're going to talk today about some fish biology facts that I hope you find interesting, and some about the region that we're in as well. How do I show my slides? Yep, Jamie's helping me.
So while we're having a break here, Dr. Ellen, I did set up a board over there on the side, guys. If you have questions, if you want to write them down, and then we can ask them later.
Yeah, please do.
Okay.
Yeah, please do. We're going to have some breaks for questions. So if you have some, if you're on Zoom, you can put them in the chat, or if you want to write them down there, we can just address them when we go. Yeah. Oh, that's fine. Yeah, it's all good. Okay. Very good. So I want to, and that's a bit about me and just my background, but we don't need to go into too much of that. This is the Big Bend region of Florida, as I mentioned here. It's up in the northeastern Gulf of Mexico. So north of Tampa is where we are. We're in a little town called Cedar Key, which is a town of 700 on an island that's about 3 miles out into the Gulf of Mexico. So I don't know if any of you have been to Cedar Key, but if you haven't and you ever come here, come see us here at the Biological Station. This is the Nature Coast Biological Station located right on the shoreline in Cedar Key. And we are a station that does research, teaching, and extension, public outreach about natural resources. So we're focused on things like fish and wildlife, high quality habitat, those kinds of things as a program that we do here. I'm a fish biologist, so we'll talk a bit about fisheries and a few interesting facts. So the fish in the upper right of the screen here is called the spotted sunfish. That's the official common name in our science world, but it's affectionately known in Florida as the stump knocker. And the stump knocker, and the reason it's called a stump knocker is that these fish are found in rivers and they tend to be around wood type habitat. So we find them around lay down trees, logs, that kind of stuff. That's where you find this fish. And it's a really popular game fish and also a beautiful little sunfish. The one on the lower right is a snook. That's actually just from a couple weeks back here at Cedar Key. And again, a common game fish that's expanding in our region. Fisheries are really important in Florida, up to $10 billion annually in total expenses. I'm sure many of you have been fishing before. A lot of people come to Florida just to fish. Fishing recreation is a big deal. It's a big part of our tourism-based economy. And so one of the things that I've focused on in my career is how do we sustainably manage fisheries, and how do we ensure that our fish populations are going to be healthy in the future. To do that, we have to factor in all parts of a fishery, and a fishery includes the fish themselves, the people, the human users, and the habitat. So we spend a lot of time working on all aspects of that. How do we study the fish biology? How do we study what anglers want from fish populations? How do we protect shoreline habitats and things like salt marsh and mangrove and oyster reefs and those kind of things that directly affect fisheries? So that's a big part of what we do in science to try to improve fisheries in the future. Things can be really controversial. You know, back in 1994, before you guys were born, the Florida created a net ban, a Florida net ban where they banned gill nets in state waters. Now that may seem like a good idea, but it actually put a lot of people out of work, and I feel like it was not a good science-based decision. I think that they could have allowed netting to continue and done it in a sustainable way with proper regulations, but instead they banned the nets, and so this is really controversial and creates a lot of angst and a lot of problems. So these kind of public policy debates are central to fisheries management and natural resource management. So it's there are challenges in any of these kind of debates. I mentioned that, so I'll let that go. This is a spotted sea trout here on the right. You can see the kind of Dracula two-fanged teeth that's characteristic of a spotted sea trout. They use those two teeth to hold on to their prey, and a very effective predator. I've done a lot of research looking at how do we sustainably manage fish populations. How do we set harvest restrictions? How do we set things like bag limits, size limits, closed areas to make fish populations sustainable for the future? And so that's a big part of what we do. I'll put the tank behind us. And so that's a part of what we do. Part of that is actually computer modeling. We actually build computer models to predict what will happen to fish populations in the future if we change management actions. Part of that is also data collection, where we go sample fish and understand the biology of the fish. One of the interesting ways that we do that is trying to determine the fish age. And I wanted to show you this. We actually use ear bones, which are called otoliths, to age fish. And these ear bones are floating inside a capsule, inside the fish's head, inside the skull infrastructure. When a sound wave penetrates through the water and hits the fish, it creates a vibration, and they detect it by the vibration of these bones that stimulate nerves and send a signal to the brain. Very similar to us and how you're hearing me right now. I'm making a vibration and a sound wave that comes through the computer, and the little bones in your ear wiggle microscopically in response to that sound wave and send a wave to your brain, and so you can hear me say hello. Fish hear exactly the same way, but they do it with these otoliths. Now, the otoliths are interesting because they're floating bony structures inside of the skull, but these structures grow at the same rate of the fish. And fish generally grow faster when it's warm and slower when it's cold. What that does is create rings on the otoliths, just like rings on a tree. And by examining the otoliths, we can tell how old a fish is. So this fish, if we count the white or the dark bars, let's count the white ones, for example. This fish would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is about an 11-year-old fish, and we can determine that from the otolith. And that allows us to use the fish biology to say how old the fish are in a population. And fish populations that don't have old fish can be overfished because the old fish are removed. And so we use an indicator of how many old fish are in a population to see whether fishing has been a problem. So the biology of the fish feeds right into the management. And that has impact on tourism and all the things that make fisheries important. Can fish see color? You know, this fish on the left-hand side, many of you might have caught in freshwater lakes around your area, is the largemouth bass. And the Florida largemouth bass is an iconic Florida sport fish and found in freshwater systems throughout the state. If you see any little pond around on the side of the road, you can almost guarantee that largemouth bass are in that pond. Any river or freshwater system in the state has bass. And they do see color, and different fish species detect different colors. So the graph on the right shows some different fish species. In general, fish can see the shorter wavelengths, the blues and the UV colors, better than the longer wavelengths, which are like the red type colors. And it varies some across fish species, so you can see that there. So yes, fish can see colors, and how which colors they see does vary some across fish species. So we'll stop there for a question break and have a chance to have any discussion, and then we'll continue on. So any questions so far from the group? I can't see the chat, so if there are, let me know.
Yeah, can you hear me?
Yes.
Yeah, they are shaking their heads. No,
Okay.
I put one on my board though,
Okay.
but you might address this later about our issues in Hillsborough County with the Piney Point issues with the wastewater, and do you think it's going to go your way and affect anything up there?
Yeah, that's an excellent question. And, it's something that I've been following closely, like most of us in Florida. That area is very naturally very high productive sediments, and the soils in your area have a lot of phosphorus, and that's what has caused the phosphate mining and that kind of stuff, which they use to make fertilizer. That reservoir, the Piney Point system, they're trying to pump it down to prevent a catastrophic flood that would flood homes, which obviously would be a strong negative. It's obviously not a good situation, and definitely there's a pollution aspect of it, mainly because the water in those ponds is full of algae and full of nutrients. And so the expectations I would have is that by pumping that water and releasing it into the systems that drain into Tampa Bay, we're likely to see some algae blooms associated with that, which would have a short-term negative effect. If it were to sustain over a long haul, I would be more worried about persistent algae blooms or even red tide blooms down the road. And red tides cause massive fish kills due to the toxins that those algae put out. So it's not a good situation, and one that the state is monitoring very closely right now. And scientists, my email blew up this morning with all kinds of feeds of people talking about the potential implications. I do expect this to be a relatively short-term effect. It's a lot of water, and it's a big number, millions and millions of gallons, but in the scope of Tampa Bay, it's a small amount of water. And I expect there to be a short-term effect in the sense of an algae bloom, but not a long-term ecological effect from this spill or this pumping of the reservoir. So it's not good, but it's not an absolute disaster. I think long-term we'll be able to recover from this without a problem.
Thank you. Thanks, Dr.
Yeah, absolutely. Any other questions, and we can continue on? Okay. We'll continue on and have a chance for more as we go. The next thing I wanted to mention is about climate change. And you may hear in the news about debates about climate change and to what degree the climate's changing and that kind of thing. As a scientist, I can make a strong case to you that our data and the data about the climate have very little uncertainty. Our climate is warming. The air temperatures are getting warmer every year. These plots I'm showing you on the right are the water temperatures here in Cedar Key, and this is just over the last 20 years. You can see that the water temperatures are increasing. We're having less cold winters, less extreme cold events, less number of days where the air and water temperature is below 25 C, which is about 75 degrees Fahrenheit. So we're getting more and more warm days, and that has big implications. And it's also causing sea level rise from a global perspective. Our sea level in this part of the Gulf is rising actually faster than some other areas of the South Atlantic and Gulf of Mexico. Our sea level rise is about 2 millimeters per year on average. Now that may not seem like a lot. That's about the thickness of 2 pennies. But if you think about that only over a period of say 10 or 12 years, and then you put on top of that a thing like a hurricane or a storm surge on top of sea level rise, it can have big effects to fish, wildlife, and people in regards to flooding and storm surge. So these are effects that we're seeing daily, and we're seeing big changes in the natural environment because of this. One of the big changes is shifting distributions of fish and changes in habitat. We're having what was historically salt marshes being transferred over to mangroves. Mangroves are also beneficial habitat, but they're tropical species, and they're encroaching further and further north, directly into our area now in Cedar Key, which isn't necessarily bad, but it's a change in habitat from what was here historically. The snook that I showed you earlier, and that's him right here. This snook is an iconic game fish in Florida, but historically the northern range of snook was really about where Hillsborough County is. Really, Tarpon Springs, Pasco County was the northern range of snook in Florida. What we're seeing now is that snook are extremely common in the Cedar Key area and even north of here, north of the Swanee River. So this fish has expanded its range about 100 miles further north into the Gulf of Mexico. It's a very popular sport fish. It's also what we call a protandrous hermaphrodite. That means that all the fish are born males, and they switch from male to female somewhere between about 18 and 22 inches in length. So snook die if the water temperature gets below about 50 degrees Fahrenheit. And so because of the warm winters we've been having and the warmer Gulf and climate change effects that we're seeing, the snook have increased and are now very common in our zone. They're very common in your area as well, along the coast and in the rivers. If there's any river that has an open access to the Gulf, you'll have snook in there. Snook are very happy to live in fresh water, and so you find them in the rivers commonly. But that's been a real range expansion. This is one indication of climate change, but there's many others. We're seeing a shift in fish and bird communities. Now we have spoonbills, roseate spoonbills, the pink birds. There's a schematic of one right up there. I don't know if you can get that one, Caroline, but we have a picture of a model of a spoonbill here in the lab. And those birds never nested here historically. Now they're very common in our area. So Carolyn's reaching her arms very, very high to try to get the spoonbill. So thank you, Caroline. And so this is another indication of a shift in distribution of animals, both fish and wildlife, in response to climate change, which is really, really common that we see. Here's an example of a snook expansion in the Gulf. You can see Tarpon Springs and Hillsborough County is just south of there. Tarpon Springs is the historical native range of snook, and now they're found north of the Swanee River. So the black line there north of Tarpon Springs is the new expanded range. And the graph in the lower right is the snook catches from the State Game and Fish Agency here in Cedar Key, and you can see that they never really caught snook before about 2005, and now snook have just increased exponentially and continue to through this year into 2021. So climate change is real. Climate change is happening. We're seeing big changes in the fish community as a result of that. I want to mention that one way we catch snook, which is kind of interesting, is what we call electrofishing. And electrofishing is using a boat that has a generator and actually puts electrical current into the river or into the water, and it works well in rivers and lakes in coastal environments. It's a freshwater gear, but it works well for snook in the rivers. We can actually shock, and those booms out on the front of this boat are actually putting electricity into the water, and then those folks on the front can dip those fish up. And then we can use them to tag them or collect fish for otoliths, for aging, or any of those kinds of samples. So electrofishing is not legal. We have to get a permit to do it scientifically to be able to catch the fish. But I can say it's a lot of fun, and it's a good way to collect fish, so we do that as part of our snook sampling. Any questions there about climate change, changes in species distributions, anything about the Piney Point issue, or any of those kinds of things? Any questions?
Nothing yet? All right. How many of you are going to take marine next year? Marine science? I thought there was a couple. You guys have to have your course requests in by tomorrow, right? So hopefully hopefully you've got it. You talk with me too about what your choices are. I know we're just kind of going off topic here, but not really, because I think that, you know, we live in such a beautiful state with so many fish and so many natural habitats that we are learning about. And, you know, this is chemistry class, but we are teaching science as well in general.
Sure, absolutely. And chemistry is a really important part of this. I mean, the water quality and some of the issues around the Piney Point example are trying to understand what the effect that's going to have on the environment. That water that's entering from Piney Point is low pH, it's high acidity, and that could have some impacts as well. I expect the impacts to be short term, but chemistry is at play in any of our scientific disciplines, and so it's important. And as a marine science group, for those of you that take that class next year, lots of opportunities, of course, in Florida to study all kinds of things from seagrass to fish to birds and everything in between. So we are fortunate to have such a great marine environment in Florida, and it's literally a living classroom for these kind of classes. So excellent. Any other questions or thoughts there? My next section, I'm just going to talk about a few examples of fish species, a little bit more fish biology, and then we'll have time for some more questions. Okay? All right, we'll go ahead. I want to mention a few other fish that are iconic fish here in Florida, and one question I have is, how many of you have ever caught a spotted sea trout? Anybody that can raise your hand in there? Have you caught a spotted sea trout? I'm looking at you. I see you. Can you raise your hand? Nobody's caught a spotted sea trout? Man, y'all caught snook, but not spotted sea trout. That's impressive. Okay. Well, the spotted sea trout is, you know, it looks like a trout. Like it's a physical appearance. It's a lot like a rainbow trout or something like that you might buy in the grocery store. But the spotted sea trout is actually not a trout at all. It's a member of the drum family, which is a broad collection of species that is in the family Cyanidae. And it's a neat complex of fish that's really important ecologically and economically for people. 275 species of drum around the world, and the spotted sea trout's one of those. It's characterized by having a swim bladder, and the swim bladder allows it to control its buoyancy in the water, but they use the swim bladder and muscles around it to create a croaking noise, and that's why they're called drum. It's because they make a drumming sound. And that croaking noise is used to communicate with each other, a lot of times around spawning. And in the case of the spotted sea trout, they actually, the males croak a lot when they're trying to attract females into these schools to spawn. And so when you catch a spotted sea trout, if it's croaking on the boat and you hear the sound, it's a male. And they do that naturally when they're stressed out after being caught, or when they're in a spawning aggregation, they croak to attract females. And we actually can put a hydrophone in the water and use the croaking sound to actually try to find spawning aggregations of these fish. So they're really important sport fish in Florida and the Gulf of Mexico, and very common for anglers to pursue. Another big one that's important in Florida, we have them in the tank here, is the red drum. And they're another member of the Cyanidae, the drum families. They get much bigger. This picture is with a red drum with one of our Sea Grant agents, Brittany Sharp, and it's a popular sport fish. This is a real success story because red drum were historically overfished. They were popularized by a chef in New Orleans that popularized the dish blackened redfish, and blackened redfish became so popular that this whole fishery developed where people would go offshore and find these spawning aggregations of red drum out in the Gulf of Mexico, and they find them with spotter planes and then send these big vessels over there with purseines and actually catch up all these spawning red drum. And what that caused is classic overfishing, and red drum populations were really in trouble in the early 1980s. We instituted much stronger regulations on commercial and recreational harvest throughout the Gulf. And now red drum in Florida are not overfished at all. They're at very healthy levels. And one of the points I wanted to make to you is that you hear in the media a lot about, there's all this pollution and the oceans are overfished and there's all these bad news out there. And there is a lot of bad news worldwide. But in general, many of our fisheries, particularly in the United States, are very well managed. Our snook populations are not overfished. Spotted sea trout are not overfished. Red drum are not overfished. We manage them sustainably. And so that's an important thing that you could even quiz your parents about, because fishing is not all, overfishing is not as common as a lot of people may think. So what can you do out there to help promote good aquatic resources moving forward and sustainable fisheries? And one of the things is follow the harvest restrictions that are in place, like bag and size limit. I tell people to only keep the amount of fish that you need. You don't have to fill a freezer with fish, and you can just keep what you want for dinner and release the rest. Almost all of our fish species, if you catch and release them, they have very low mortality from that event. So you can release the fish, and it'll continue growing and spawn in the future. And then a big part of this Restore the Shore program is about protecting fish habitats, seagrass, oysters, those kinds of, and mangrove habitats, which are really the basis on which we have fishery resources. We're not going to have fish to catch and fish to eat if we don't have good habitat. And protecting aquatic habitats is really a key part of what we're trying to do in science and to promote good management of coastal systems. So I encourage you to think about what you do. And some of that could be water conservation to protect freshwater resources and the amount of water entering estuaries, and also things like seagrass safe boating so you don't churn up seagrass, and protection of shoreline vegetation, those kinds of things. So I really appreciate the group taking time today, and I'm happy to answer any questions and have any discussion. And thank you for listening. Appreciate y'all listening. And any questions?
Anybody? Any questions?
Any questions, gang?
Doesn't look like it.
Okay, I understand. And I'll also mention that if you do have questions about careers in natural resources, wildlife, fisheries, marine science, any of those things, get with your teacher. She has the contact information for our team, and we're happy to respond to any questions there or give answers, or try to help out with career decisions and those kinds of things. So don't be hesitant to reach out to us. So we appreciate y'all listening. And,
Super.
Yeah.
Thank you, Dr. Allen, for your time.
Yeah, I hope y'all enjoy the rest of your day. Thank you.
Thank you guys so much. If you have any other questions, feel free to see our Streaming Science website. And again, we'd like to take this time to thank Dr. Allen for speaking with us today. And we hope that you guys join us for our later programs. Thanks, guys.